What's up geeks, and welcome to the channel. In the previous video of this series, we redesigned our initial Spring Boot project to follow more of a clean architecture mentality. And the main idea we focused on was the isolation of the business logic and the domain from other parts of our application. To do that, we followed a layered architecture approach, allowing us to isolate the domain, which is the central part of our app. Now, as part of these previous videos, we also abstracted all database access into a single interface. By doing this, we decoupled storage options from the whole code, allowing us to select different implementations based on a certain configuration. In today's video, we're going to add a new implementation to our database options. We made use of this implementation in our Docker series if you're following that one. This implementation will make use of a Postgres database, which we will cover in detail. On top of that, we'll explore the key concepts behind the Flyway framework and how we can use it to continuously remodel our application's database schema reliably and easily. You see, Flyway updates a database from one version to the next using migrations. We can write migration schemas either in SQL with database-specific syntax, which is what we're going to do in this video, or in Java for advanced database transformations. To make use of Postgres locally, we'll need to install it. I'm not going to go through that here because it is a straightforward installation, but I'll leave the link to Postgres downloads page in the card above. Make sure to install pgadmin alongside Postgres Server, which is an open source administration and development platform for PostgreSQL. To make use of Postgres and Flyway, we need to start by adding the following Maven dependencies to our POM file. After doing that, we'll have to create two nested packages, db and migration, under our app's resources folder. Inside this folder, we will store Flyway's migration schemas. Then do not forget to add their corresponding properties in the application.properties files, as you can see in front of you. Let's go ahead and try to do our first migration. Flyway adheres to the following naming convention for migration scripts, where you should specify a prefix for the version. By default, it is simply the letter V, followed by the version number. Major and minor versions may be separated by an underscore, then two underscores, and then a description. So, after creating the directory db migration, let's create a migration script named v1_1 initial.sql containing SQL instructions to create the video entity table we've been using throughout this series. On top of this, do not forget to create a sequence that will be used by Postgres to auto-generate the video ID pointed out by the red arrow, as this is not done automatically. After doing this, simply attempt to run the Spring Boot project locally and these SQL commands will be executed automatically on your local Postgres instance. We can verify this by navigating to pgadmin, and under tables we can check that the video entity table indeed exists, and under sequences the video ID sequence exists as well. If we attempt to retrieve all the rows of the Flyway schema history table, we will see that it contains a single record, and that record is none other than the file we just created. Since the application is running, let's navigate to the Swagger endpoint and attempt to insert a video record in our video table. After doing that, retrieve the rows of this table. We can see that the expected record is indeed there. Let's go ahead now and attempt to add an attribute to the video entity class. When we do this, we can't simply go ahead and update the SQL schema we just created, as this will lead to errors when we restart our Spring Boot application. You see, this schema was already executed. This migration was done. It is over. Any new modification would have to be applied using a new SQL file added under the migration folder. So, to apply this change, we will have to create a second migration file, and inside this file we write down the SQL command that is going to alter the video table for us by adding the channel column to it. Notice how we increased the minor version in respect to the schema we previously created. After doing this, rerun the Spring Boot application. We can verify that both migrations are indeed executed and finalized by navigating to pgadmin, and under tables we can check that we have two records in the Flyway schema history table. Finally, to tie everything together, navigate one last time to the Swagger UI and attempt to make use of the APIs we previously exposed. If we hop back to pgadmin, we will see that the record we previously inserted and the one we just inserted are still there and will remain, allowing us to make use of them in future instances of the application. Let us know in the comments below if you'd like us to dive deeper into Postgres and Flyway with Spring Boot. And that's it for today. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.